Dome houses, architecture of the future. The architecture of the future is not only about aesthetics and the beauty of forms, it is also about functionality, providing protection, reliability, and adaptation to the surrounding environment, such as climate challenges, weather conditions, and more, including the application of cutting-edge technologies like AI, automation, future energy solutions, etc. One type of future architecture is dome houses. Today, we will explore why Jacques Fresco considered them the architecture of the future and what they can offer each of us. About Futurism and future architecture. Logically, architecture answers a fundamental question: why do we need a house? Initially, it was our hearth, protection from bad weather, and a place to rest. Over time, we began to incorporate engineering and art into our lives, blending technical convenience with aesthetic beauty. There are different architectural styles, such as classical, modernism, brutalism, futurism, etc., each reflecting the stage of human development and intellect. Art acts as a neurostimulator, fostering creative thinking, inspiring revolutionary ideas. Therefore, architecture should serve both engineering and artistic purposes. Future architecture also involves high technology, incorporating advanced energy systems, computer networks, AI, autonomy, and more. Safety and cities of the future. When it comes to safety, we must first study the geography and local climate of the construction site, determine which shapes are most suitable, select durable materials, and plan the construction accordingly. It makes sense to build structures based on the environment. If hurricanes are frequent, dome houses are preferable. If earthquakes are common, tall buildings should be avoided. As for entire cities, future cities must be planned, not spread chaotically like current cities. Cities should serve specific purposes: research, science, engineering, industrial, etc. If we imagine a unified, civilized world, people will plan the future with goals such as space exploration, scientific progress, technological development, and ecological preservation. Cities and population distribution will be organized accordingly. Future cities will combine aesthetics and perfect engineering. Today, we focus on dome houses. In future videos, we will cover futurism, future architecture, and the world of tomorrow. Enjoy watching. The essence of a dome house. A dome house is a building shaped like a hemisphere. This geometry is found in nature. From eggs and shells to planets and galaxies, it's no coincidence that futurist Jacques Fresco said, "Nature itself shows us the most stable structures."
Not everyone will choose to live in a dome. They will choose to live in whatever architectural shape would meet their needs. The reason why we suggest a dome is it uses the minimum amount of materials and covers the maximum areas and offers maximum strength. So the dome shape is included in almost all of nature. Your brain is in a dome. The cranial case is in a dome. So if a person says, "Yeah, I don't think I'd want to live in a dome," you've been living in a dome most of your life.
Indeed, our teacher and predecessor is nature itself. Advantages. Dome structures can be used in any climate: Arctic, deserts, equatorial regions, as well as under various natural threats. The reasons lie in their geometry and physical properties, aerodynamics, and resilience to natural disasters.
Designs and materials both with a purpose. The shape isn't just to impress, right?
Not at all. No, you live in a dome right now. The cranial case is a dome. And the cranial case is very strong.
Hurricane-proof, termite-proof, fireproof.
And it gets stronger every year. Your building needs very little maintenance. You can wash the whole building with a garden hose. And the cost would be way down.
Domes have almost no corners or flat surfaces, distributing the load from wind, snow, or sandstorms evenly. In the Arctic, this prevents destruction from strong winds and heavy snow. Snow slides off easily. In deserts, it withstands sandstorms. Domes resist hurricanes, strong winds, and even earthquakes. In aerodynamic tests, for example at Florida International University, dome houses withstood winds up to 300 kilometers per hour, while traditional homes fail at 150 to 180 kilometers per hour.
In southern Florida, millions of dollars and buildings were destroyed by the big hurricane there. And they put up buildings that looked just about the same. Now, if you don't want hurricane damage, an inverted cone, it's almost impossible for a whirlwind to pick up an inverted cone. So we would have these shelters built in the West Indies or wherever hurricanes occur. And inside would be pull-down bedding, food storage, and emergency water. So this is the kind of form that no vortex or wind can pick up. Try to pick this up with greasy fingers. And that's similar to the wind whirling around it.
Fact: during Hurricane Ivan in 2004, almost all Florida coastal houses were destroyed, but the monolithic dome survived. Japan, 2011. Dome houses in Miyagi Prefecture built using the dome house system remained intact during the earthquake. Energy efficiency. Domes have minimal surface area for maximum volume, reducing heat loss in cold climates and overheating in hot climates. The dome's surface area is 30% smaller than a conventional rectangular house of the same floor space. Fact: monolithic domes consume 50 to 70% less energy for heating and cooling compared to regular buildings. Monolithic Dome Institute data. Material versatility. Domes can be built from local or modern materials: ice, igloos, sand blocks or clay, wood, concrete, modern composites. Thanks to even load distribution, less concrete, steel, and wood needed. Bionic principle, aesthetics, and psychology. Dome shapes mirror naturally stable structures: cells, seeds, planetary bodies. This universal shape suits different environments because nature has optimized it. Domes create a sense of harmony, connectedness to nature, and resemble natural structures in the universe: planets, atoms, molecules, biosphere, and even the shape of the human head. Construction speed. Modern technologies, including 3D printing and inflatable forms, allow dome houses to be built faster than traditional houses. A monolithic dome can be constructed in 4 to 8 weeks, including preparation and reinforced concrete shell. Inflatable forms, airform, speed up the process and reduce labor needs.
Computer-controlled robots will handle 90% of the movement and placement of prefabricated components. Special advanced materials are to be developed, eliminating waste and minimizing the need for manual labor. Guided by satellite and using a sophisticated form of artificial intelligence, the buildings will construct themselves, a technique Jacques has named self-erecting structures.
Fact: a dome house in Texas was built in 6 weeks by a minimal crew. Fresco suggested using machines, robots, automated 3D printers to create forms faster than brickwork, enabling mass and inexpensive construction. Strength and durability. Dome houses are usually built from reinforced concrete covered with a protective shell. They are resistant to earthquakes, wildfires, floods if built on raised foundations, lifespan 100+ years with minimal maintenance. A few nuances. Furniture and interior design are more challenging. Standard cabinets and shelves may not fit, and window shapes may require custom solutions. Geodesic domes have many joints. Poor assembly can cause leaks. Where dome houses are especially relevant. Domes are particularly effective in areas where nature challenges humans, in hurricane and tornado zones, in permafrost regions, in hot deserts, and even for space projects on the Moon or Mars. This is not just Jacques Fresco's architectural trend. It's a scientifically and practically proven solution that meets the challenges of the future. Dome structures can be used not only for individual homes, but for entire dome cities, protected from the environment. Dome houses are an architecture that combines aesthetics, efficiency, and sustainability. Jacques Fresco believed that such projects can make housing more accessible, durable, and eco-friendly. What do you think? Could you live in such a house? Share your thoughts in the comments. We're very curious. Subscribe. More ideas about cities and future architecture are coming soon.